Hello everyone, this is going to be my attempt at making a 3D printed internal combustion engine. I'm going to be using 1.5 inch copper pipe as my cylinder sleeve, and all the other parts like the piston, connecting rod, head, crankcase, all of that is going to be 3D printed on my Ender 3 Pro. Shout out to Camden Bowen. You can correct me if I'm wrong. I'm not sure if that's how you pronounce your name, but you are a great YouTuber and I love watching your videos. Everybody watching this should go subscribe to him. He is the inspiration for this video, and I'm going to be putting my own little twist on my 3D printed engine. So I guess we're gonna see what happens, and this is gonna be part 1. Hopefully it doesn't take me a year, but hey, I'm going to put my own little twist on things, see how I can get it to go. Right here is going to be the first step I'm going to be taking. I'm going to start cleaning up the outside of this, and then I'll have to find something to clean out the inside of that. But I also want to say, Camden Bowen, you should go subscribe to his YouTube channel, but also because he posted his videos is why I'm going to be posting my videos, because his videos taught me a lot of stuff, and I am going to be learning using his failures, basically. And same for you guys. If somebody else wants to do this, I encourage you to film it, which is a lot more work, as I've realized getting into YouTube. It's a lot more work on filming what you're doing. But also, I think it's very helpful because with Camden filming his videos and I watch them, I can learn from his mistakes, basically, which is super helpful. And from him posting videos, he learns from his mistakes, and I learn from his mistakes, along with everybody else watching. So I think it's very nice that he is posting those videos, because he could have very well just posted a video of it running, and that's it. But him building it is a very good portion, because I can learn off of his mistakes along with everybody else. And so that's why I'm posting these videos. I'm going to start off by just trying to clean this, and I guess I'll come back to you when I can get it as clean as I can. I actually just resorted to doing this, which I'm almost done now, but I just have the shop vac hooked up for the dust, and it's working much better. I just went over it quick to see how well it'd work, and now I'm going to go over it again and actually clean it, and it's working really good. Well, that worked a lot better. This took me like 5 minutes, and I did way more than I needed to because it was satisfying. But yeah, pretty big difference. I mean, it's not perfectly clean, but that's as much as I'd ever need it. In fact, that's actually probably too much, but it's not gonna matter. It just looks better now. But yeah, now one more problem: to figure out how to do the inside. So I'm gonna try to come up with something, and I'll show you guys when I get that. But first, for cleaning out the pipe, I just tried using a wire brush on the end of a drill, and it didn't work too well. It left a lot of residue in. All it did was cleaned out like some of the bigger chunks out of the bottom. But then if I go to the other side, I used this right here, and it's just a little disc on my Dremel from this kit. And the Dremel's small enough I can get all the way up to there with it, so it gets a lot farther in than that. And that disc right there worked really well. It's a little rough, so I went over it with one of these felt discs, or I'm going to go over it with one of these felt discs. And hopefully it makes it not so rough, but that looks pretty good. And it's not rough to the touch, it just looks rough. But yeah, I'm going to go over it again and see what I can do. So here it is. Here's the finished product. Got the inside. It looks rough on camera, but I can run my finger across it and it feels completely smooth. So I'm not sure why it looks like that. Might just be little tiny scratches that are reflecting a lot of light. But it's super smooth on the inside. Like, I can't feel any scratches. So I think it's going to work. And I also polished it up some more with a felt disc, so should be very smooth on the inside. So I'm not exactly sure why it looks like that, but it'll work. So yeah, now on to the next part, CAD designing. Also, one thing I forgot to mention is it is perfectly round. Basically, it fluctuates less than 0.1 millimeters, so it's perfectly round. And I just measured how deep down I got it clean, and it's about 3 inches. So I have 3 inches, and worst case scenario, I don't think I'll need to go longer than that, but if I ever do, I can just sand it down if I get farther. So yeah, it's perfectly good. Now I have the cylinder cut. I went with 4.5 inches. I am gonna have to clean the bottom out a little bit. I went with 4.5 inches to give myself a little bit of wiggle room for when I have the piston, depending on how tall the piston is, so it doesn't stick out the bottom. But this is 4.5 inches. I might need to trim it, but my dad had this really handy pipe cutter that will work. He had a smaller one and a larger one, but then he had this one as well. So worked really well. And I got it cut nice, and now I just need to clean up this one side. I'm back in the house, and here's what the cylinder looks like. It is super clean. Still looks rough for some reason, but I hit it with the felt disc, and it's feeling really smooth on the inside of there. No rough. It doesn't feel rough on the inside, but yeah, I think that'll work. Now I can continue with making the cylinder housing and everything in CAD. Okay, so in the CAD designing, I have made the cylinder housing and the piston. The piston I'm actually 3D printing right now over on my 3D printer, and I'm going to test fit it to see how it fits in the copper pipe. But the cylinder, the quickest I could get it to print is supposed to be 18 hours, but it has a water cooling jacket, and I actually have my 3D printed pump over here that I have 3D printed. It's a water pump that has and I have some 1/2 inch inner diameter hose that I'm going to use to run water through the engine to try to keep it as cold as possible so it doesn't overheat and melt the plastic. But I have about 7 millimeters of clearance on each side for water to flow through, and I'll pump water in through the bottom, make it fill it up, and go through the top. And then I've got my bolt holes there. I still have to design the head and the crankcase and everything, but so far it's looking pretty good. Alrighty, so right here in CAD, I have the crankcase right here, piston housing right here, and the piston just got done off the 3D printer. And this is what it looks like. I think it might be a little small, because if I put it in here, it fits in there nicely, and if I close my hand, it slowly goes down there. Still don't have any piston ring on it, so I won't know for sure until I get a piston ring on it, or an O-ring. But if I hold my hand on there, it slows it down quite a bit, versus when I don't have my hand on there. So it's working kind of, but I think it's a little bit on the small side because it's got, yeah, on the small side because it's got a little bit of play in there. But I won't know for sure until I get the O-ring on there. So for now, it'll work. Okay, so I just had a minor change of designs. So I had issues using a 2.5 inch stroke length. The connecting rod would hit the side right here. So I had to drop it down to a 2-inch stroke length, which saves me 3 hours on printing the cylinder housing. But the copper pipe is now, I'm only going to have an engine with about 57 cc's instead of the 72 cc's I'd get with a 2.5 inch stroke length. But the engine still, it should rev higher with the shorter stroke length. It's just not going to have as much torque at low end speeds. But yeah, I'm very close to being done with the crankcase, cylinder housing, and then I'm going to start working on the head pretty soon. But yeah, that's what I've gotten so far. Well, I have the cylinder housing printing right now. In my enclosure, I have it printing with some Hatchbox ABS because of its high glass transition temperature, which is about 105 degrees Celsius. So that will be useful for making the cylinder housing. Although these parts are printed out of PETG, which I think I'm going to have to reprint them anyways, but I think I will use my carbon fiber filament over here for that because its glass transition temperature is 115 degrees Celsius, and it's also carbon fiber reinforced, so it's stronger. But yeah, I've started work on the head. I need to find some valves that I'm going to use. I'm going to either have to cast them out of aluminum, or I'm just going to use a screw with a really wide head. Either way, I'll have to find valves, and this is going to get done at around 10 o'clock tonight, so I'll update you guys when it's done. So this is my first time 3D printing with ABS, and I printed it for the cylinder because it's very high heat resistant, and it pops right off the build plate, and the supports are super easy to remove. I pop the bottom one off, flip it over, pop the top one, boom. Comes out that easily. and it's smooth already. That is crazy. I will definitely be using ABS more in the future. It was super easy to print. Well, it's been quite a while since I've made a update, which this will be getting added to part 1 still, but I think this might be the last part in part 1. I got the entire crankcase done, and I'm currently working on a new piston because that one is a little bit too small for the O-ring to fit around, and I'm currently making another one right now. And I think this will be the last part in update in part 1, but all my parts showed up, and I got to make the crankshaft and then design the head and everything, which I'm getting the carburetor tonight. So that will be the last step in this. I'm not sure how many more updates I will be doing for part 1, but this may potentially be the last. So yeah, this may be all for this video, but if there's another section after this, then I'll have to do more updates. Okay, so this will be the last part of part 1, and in this part I actually just made the 2 pieces of the crankshaft, which this will be flipped over, and then there will be bolted together, which will go through there. And I had a minor change to the pistons, well, major. I decreased them by almost half, and then also with these all thread rods I had, I welded a nut on the top of them so that I can more easily screw them in there. And I have the head and everything designed and the camshaft, and I still have to print out some parts, but I'm going to finish making the crankshaft, but that will be for part 2. This is going to be the last part of part 1, so thank you all for watching, and stay tuned for part 2.